My name is Ms. Popelka, and today I am going to be answering the question, what are functions? And I'm going to give you a better, more specific mathematical definition later, but for right now we're going to start with a special relationship among certain numbers. So a function, for now, we're just going to call it a special relationship that certain numbers have. And before we actually deal with the numbers, we're going to activate a little bit of background knowledge. And I am willing to bet that just about all of you guys have been, either you've been somewhere on vacation or you've at least heard of a little contraption like this, little machine that says press your own penny into a souvenir design, where you take your penny, stick it into the little machine, it kind of goes through, it flattens out your penny, and when your penny comes out of the machine, it's flat, and then it's got some kind of a nifty design that is a souvenir to remind you of your visit to wherever it is that you went. I know I've been to the Louisville Zoo here in town before, and they have something like that, but I'm sure a lot of you guys have been to other places too. Just in case, we're going to watch this nice lady who was kind enough to post herself on YouTube flattening a penny. So she's getting ready to walk over to the machine.
Hi, we're going to swap the penny at the Queen Mary. It's a great to see here.
And she's putting in the penny. Putting the penny in the machine. The penny is traveling through the machine. Any second now you're going to see it kind of making its way. There it is. Kind of through there being flattened. And then it's going to come out of the machine. Nice and flat, with some kind of a design to help remind her of her visit to the Queen Mary.
Lost penny from the Queen Mary.
Now, I'm sure right now you're sitting here thinking, what in the world does that have to do with mathematics? And I promise I'm going to get to that in just a second. So let's use that real-life example. And I know we're doing some fabulous drawing here right now. Okay, so this is our little penny making machine. It's a nice little lady, came over to the machine, and she put in just her regular old penny. There's a word for when you stick something into a machine, and it's called input. And if you think about it, that term makes perfect sense, because you put it into the machine. So the regular penny is the input, and then out comes the flat penny, or your little souvenir, and that is called output. So the input is what you actually put into the machine. The output is what actually comes out of the machine. So it goes in, some kind of little special process comes in there, and out comes your output. Well, we've got a special machine that deals with numbers, and it's so cute. I can play with this all day long. This little guy right here is called a function machine, and it's a little imaginary machine. And remember a moment ago I told you that a function is a special relationship among numbers? Well, basically what's going to happen here, we've got our little function machine right here. I'm going to put in a certain number, which is called our input, and then something's going to happen in this little function machine. Beep, beep, beep. It's going to go through, it's going to come out, and what's going to come out is going to be called our output. Allow me to demonstrate. So we've got a couple different options here. I should notice that Math Playground up here, this website, is a fabulous website that has all kinds of really cool manipulatives and stuff to play with. This is just one of the gazillion different hands-on activities that they have. I highly recommend it. So for this function machine, it's saying that I can decide the input or let the computer decide. Well, I want to decide. So I'm going to put into the machine, I'm going to put in a 10. So notice how the 10 plays. It's working, it's working. It spits out a 7. I decide the input. Let's put in a 20. It's working, and a 17 comes out. So notice that I put a 10 into the machine, that was my input. A 7 came out of the machine, that was my output. You'll probably also notice that up above the word input is an X, and up above the Y, or the output, the word output is the letter Y, and that's standard notation that we use in the algebra world. We've designated the variable X to represent what goes in to the little function machine, and Y represents what comes out. Sometimes in a little table like this table is called a function table. It'll become probably a little bit more clear in just a second, but it's just like it sounds. It's a table of all the values of the input and the output. So, and then X is always on the left, Y is always on the right. Sometimes you'll see them written like this too, vertically, and then X is on the top, Y is on the bottom. Still means exactly the same thing though. Well, in this particular instance, they are asking us to determine what the function is. Now remember back at the very first slide, we said that a function is a special relationship among certain numbers. So by this question saying, what's the function? It's basically asking me, what's the relationship between X and Y? What's the relationship between 10 and 7? What's the relationship between 20 and 17? Well, what could I do to 10 to get 7? I'm sure I've got some very smart people at home. Some of you guys are sitting there thinking, ooh, well 10 minus 3 is 7, and 20 minus 3 is 17. Well, I wonder if perhaps that is what kind of function machine we're dealing with. So when it says, what's the function, I'm going to type in here, I'm going to take a little guess. I'm going to say that Y is equal to X minus 3. Now I want you to see what it is exactly that I'm typing in to take a guess. I'm basically saying that my Y value is equal to whatever my X value is minus 3. Well, let's see if that works. 10 minus 3 is 7. 20 minus 3 is 17. So I'm probably right. I'm going to hit go and see. Excellent! I figured out the function. Okay, so, and that is actually what a function is. When it's asking what is the function, a good way of thinking about it is to ask yourself the question, what is happening to X in order to get Y? So ask yourself the question, what exactly is happening to my input? What's happening in that little machine so that when it gets spit out, to become output? And in this particular case, Y, also known as your output, is equal to your input, or X, minus 3. Let's try another one. I'm going to reset the board here. Now, just like all over the country, there are gazillions of different penny smashing machines. Okay, there's one here in Louisville that puts a seal or a little symbol on the top that says, hey, you went to the zoo. I'm sure if you go to the Statue of Liberty, probably somewhere around there is a machine that'll smash a picture of the Statue of Liberty into a penny. Okay, there's all kinds of different penny smashing machines. Well, there's also all kinds of different function machines. Let's see what kind of function we've got this time. I'm going to decide the input again. I just like doing that for myself. So I'm going to stick a 10 into the machine. It's working, it's working. I'm going to get a 2 out. I'm going to decide the input again. Let's put a 20 in. I got a 12 out. So it's asking me function. And remember, to figure out that special relationship between the X values and the Y values, you need to ask yourself this question. What is happening to X in order to get Y? Well, 10 minus 8 is 2. 20 minus 8 is 12. I'll bet it might be, if I were going to put that into algebra language, into the form of a function, I could say Y is equal to X minus 8. Well, let's type it in here and see if it works. Y is equal to x minus 8. So I'm taking a guess right now. What's the function? What exactly is the relationship between the input and the output? What is the function? Okay, what is happening to x in order to get y? Now let's see if I'm right. I'm right. Let's try one more. We're going to reset the board. Once again, I like to choose the input. This makes me feel more in control. Let's go big this time. Let's say 100. So input, 100 is going into the machine. 50 is coming out. Let's put in something different. Let's do 50. 50 went in. A 25 came out. Those of you guys that are really smart out in video land, I'll bet you can figure out that the function is probably to go from 100 to 50, you either subtract 50 or, you divide by 2. 50 divided by 2 is also 25. So I'll be willing to bet that our function, or the relationship that joins our input and our output together, is y is equal to x divided by 2. Let's see if I'm right. Y is equal to x divided by 2. And I'm right again. Now you guys might have noticed too, x divided by 2, there are a few different ways that I could have written this function. You'll notice here it uses a fraction bar instead of that division bar. And actually, now that we're more into pre-algebra land, you're probably going to see that fraction bar a lot more often than you're going to see this little division symbol. So try actually to get in the habit of not using that, and instead just do x divided by 2. You also could have said y is equal to 1/2 times x, because don't forget, whenever you are dividing something in half, you're also, or whenever you're dividing something in 2, that's also the same thing as multiplying it by 1/2. So that could have been a different way to say the same thing as well. Let's try another example. Once again, it's asking us to find the function rule, but we're going to do one that looks more like what you're going to see on worksheets and tests and stuff like that. A lot of the time we don't have that cool little function machine to just carry around with us. So you're going to have plain old worksheets a lot of the time that just have a plain old function table with values in it, and you've got to figure out what is the relationship between x and y. So let's take a look here and see if we can figure out what the relationship is between x and y. Okay, so to go, and remember, you've got to ask yourself the question, what is happening to x in order to get y? So what is happening to x in order to get y? Well, to go from 1 to 3, we can add 2. But in order for a function rule to work, it's got to work for every single pair of x and y values. Or, remember, this is also called the input. This is also called the output. So 1 plus 2 is 3. So 2 plus 2 is not 5. So the function rule is not adding 2. So, oops, tried that one, didn't work. Well, let's see if it might be 1 times 3 is 3. 2 times 3, nope, is 6, not 5. So, that's not going to work either. You can't really divide 1 by anything to get 3. Well, technically you can divide 1 by 1/3, but that's not going to be the same thing. So we've got a problem here because there's no one single operation that will help you to get from 1 to 3 and then also from 2 to 5. So that means we're talking about a function rule that is a little bit more complicated. We're talking about one that's actually going to involve 2 different operations now. Now, I wish that there were a really super easy way to tell you how to do this. So you really kind of have to just use some number sense. And a lot of the time you got to do a little bit of guessing and checking in order to figure it out too. So I would probably start by saying maybe if you could multiply all these numbers by something and then add or subtract. So let's see here. So multiplying it by 1 would be kind of silly. So let's start with maybe like 1 times 2 is 2. Well, 2 plus 1 equals 3. Okay, 2 times 2 is 4. 4 plus 1 equals 5. Ooh, wait a second. Maybe I've seen a pattern here. 3 times 2 equals 6. 6 plus 1 equals 7. Let's make sure the pattern holds. 4 times 2 is 8. Plus 1 equals 9. 5 times 2 equals 10. Plus 1 equals 11. Yes, we have a winner. So our function rule is, in order to get y, you have to multiply x times 2, so 2x, then you have to add 1. So our final answer is, for finding the rule, or finding the function, sometimes it's called a function, sometimes it's called a function rule. You know how we math people like to be a little bit confusing. So don't worry, we're asking you for the same thing. Sometimes they say find the function, sometimes they say find the rule, and sometimes they say find the function rule. They're basically asking you to do exactly the same thing. So in this case, they said find the rule, and the rule is y is equal 2 times x plus 1, or y equals 2x plus 1. Here's another example where they're asking you to find the function rule, or they're asking you to figure out what's the relationship between x and y. In other words, what has to happen to every single x in order to get every single y. Now, I'd encourage you to hit the pause button, try to figure this one out on your own. So before you do, I'm going to give you a little word of warning. Some people get a little bit focused on looking at the pattern over here with the y's, and they say, ooh, well, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. Okay, that's awesome. Yes, you're absolutely right. There is a pattern involved there. However, the function rule is not adding 3, because if you do 0 plus 3, it doesn't give you 2. If you do 1 plus 3, it doesn't give you 5. So be careful. Some people get hung up on what pattern is going on over there in the y column, and they forget they're really trying to figure out what the function rule is, which is what has to happen to x in order to get y. So hit the pause button for a moment, try this one out, and then restart the video when you're ready to check your answer. I personally am going to go ahead and try to solve this one myself. Now, I'm going to start off just with the obvious stuff. So let's see if just one operation works. So to go from 0 to 2, I could do 0 plus 2. Well, 1 plus 2 is not 5, so that's not it. Okay, unfortunately, there's no other way for me to go from 0 to 2. So that means, or at least just using one operation anyway. So that means I'm going to have to do a little bit of guessing and checking here. So, let's see. In our last example, multiplying by 2 kind of helped us out. So let me see if that helps me here. See, 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. So let's see if I can go back and add the same thing. So 1 times 2 is 2, plus 3 is what I would have to do to get to 5. Nope, that's not going to work. 4 plus 3 is not 8. So multiplying the number by 2 isn't going to help. Let's see if maybe, and I know to try out some kind of multiplication probably first, because I'm starting with a smaller number and I'm going to a bigger number. So let's try multiplying it by 3. 1 times 3 is 3. 3 plus 2. Let me write this over to the side where it'll be a little bit easier to see too. Okay, so 1 times 3 equals 3. 3 plus 2 gives me 5. Okay, now I'm going to try this next one. 2 times 3 equals 6. 6 plus 2 equals 8. Look, I've got 5, 5, 8, 8. So now let's try and see if the pattern holds. 3 times 3 equals 9. Oops, I got a little carried away from me there. And it's not wanting to erase like it's supposed to either. Okay, so 3 times 3 equals 9. 9 plus 2 equals 11. 4 times 3 equals 12. 12 plus 2 equals 14. And let's double check. So 0 times 3, of course, equals 0. 0 plus 2 equals 2. I have found a function rule that works. In every single case, I need to take x and multiply it by 3, and then take that answer and add 2. So the function rule for this particular table is y equals 3x plus 2. In order to get y, you've got to multiply x by 3, then add 2 to that answer. Sometimes you'll be faced with a problem that is a little bit different, where instead of them giving you the function table and you figuring out what the function rule is, they give you the function rule and you have to fill out the rest of the table. I personally think these are actually a little bit easier than the other kinds. And let's take a look at that one. My eraser is still not working. Okay, so in this case it tells us that the function rule is y is equal to -2 times x. That means to get the y values, you're going to take the x and multiply it by -2. Simple as pie. So, -6 times -2 would be +12. -3 times -2 is +6. 2 times -2 is -4. And 3 times -2 is -6. A lot of the time you can go back and check to make sure that you filled the table out correctly. If it's a true function, you should see some kind of a pattern right here in the table. So 12, to go from 12 to 6, you subtracted 6. To go from 6 to 4, actually, in this case, there's not going to be a pattern, is there? To go from 6 to -4 means you had to have subtracted 12. Going to go here means you had to have subtracted 2. There's actually not a pattern in this one, so this one's not a very good example to use to check yourself. So let's just double check and make sure that I didn't goof. So we got -2 times -6 is +12. -2 times -3 is +6. -2 times +2 is -4. -2 times +3 is -6. So I did fill out the chart correctly. Okay, this one right here says to get your y values, you take x and subtract 6. So -9 minus 6 is going to be -15. -5 minus 6 is -11. -4 minus 6 is -10. And 8 minus 6 is +2. Now, it would help for you to be able to check to see if there's a pattern. If these guys right here kind of went in a pattern, like if your x values went in a pattern, then your y values would go in a pattern as well. But since they don't, it doesn't really help you very much. But let's double check ourselves and make sure. Okay, so our y is equal to x minus 6. So -9 minus 6 is -15. -5 minus 6 is -11. -4 minus 6 is -10. 8 minus 6 is +2. Yes, we know we did this one correctly. It's now time for me to introduce to you another very important vocabulary word that has a little something to do with functions. And that vocabulary word is relation. And all a relation is a set of ordered pairs. Now, hopefully we remember from our geometry unit exactly what an ordered pair is. It's exactly like what you use to graph. So it's an x and a y coordinate. So for example, if I wanted to turn these two values right here into an ordered pair, I would just say -6, +12. Because remember, in an ordered pair, the x value comes first, the y value comes second. Hence the reason it's called ordered pairs, because the order matters. While relation is a set of ordered pairs. You can kind of think of relation as, it's very similar to the word relationship. So they all kind of have something in common. So I'm going to create a relation out of the values in this table. So -6, 12, -3, +6, to -4, and finally 3, -6. So I've just written a relation. All a relation is just a set of ordered pairs that are hanging out. Okay, and if I wanted to make a relation for this set, I could do so extremely easily. Think in your head about what it would probably be. So -9, 15, -5, -5, -11, -4, -10, and 8, 2. So all I've done is I've simply taken the information from the function table and turned it into two sets of ordered pairs. And all ordered pairs are just the x-coordinate paired with the y-coordinate. And remember that the x always comes first. So relation is simply a set of ordered pairs. Now, in these two particular cases, we took function ordered pairs and turned them into relations. And remember, relation is a set of ordered pairs. However, not every single relation or group of ordered pairs is a function. And that is reflected by the fact that we are now being asked the question, is this relation a function? Remember, a relation is just a group of ordered pairs. And there's a special rule that you need to know when it comes to determining whether or not a relation is a function. And this is that special rule. To have a function, if you have the same x values, they must be paired with the same y values. So I'm going to say that one more time because that is very important. If you have the same x values, they must be paired with the same y values. Let me show you why. Let's go back to, and I'm just going to draw kind of a lousy version of a function machine, like our one that we were using earlier. So our function machine. And what these ordered pairs are saying, that if it is a function, a -2 is going to go in to the function machine. It's going to work its magic, and a +6 is going to come out. Well, that's totally possible. The function could be, say, -2 times -3 gives you +6. But then it's also saying over here that a -2, still the same input, a -2 went into the function machine, but instead of a 6 coming out, now it's saying that a 4 came out instead. There is no function on the planet where you can put a 2 in one time and a +6 will come out, but then the next time you put in a -2, a +4 will come out. There's just no such thing. So, if you have the same values that that go in to the function machine, they've got to have the same y values that come out. There's another example in this same one that kind of violates that principle as well. This relation is saying that, in this case, a -1 was our input. That means a -1 went into the function machine. It did its magic, and then a +4 came out of the function machine. Then it says down here that a -1 went into the function machine. It worked its magic, but then this time a +7 came out of the function machine. Once again, there is no function on the planet where a -1 will go into it and a +4 will come out one time, then a -1 will go into it and a +7 will come out the next time. So the rule is, if you have more than one of the same x value, that's okay. You can do that. But they've got to have the same y value along with them. So in this particular case, this relation is not a function because it violates the rule. And once again, the rule is, if you have the same x values, they must be paired with the same y values. Let's look at an example. Now, if I wanted to change that group a little bit, so let's say the -2, 4, -1, 6, -2, 4, -1, 6. Well, is this a function? Now, yes, it is a function because, yes, I do have a -2x value here and a -2x value here, but I've got a +4 to go along with both of them. Same deal here. I've got a -1 for both of my x values. However, both of those x values have a +6 for their y value. So you can have more than one of the same x coordinate as long as it has the same y coordinate to go along with it. Before we do a practice problem, I would like to talk to you about one common misconception. Okay, some people think that, okay, they understand the rule that if you have the same x values, they've got to have the same y values. And they think that the rule must work for y values too. Let's say I've got 2, 0, 1, 0, 3, 0, and 5, 0. Okay, this is a relation. What's a relation again? Exactly. It's a group of ordered pairs. They're hanging out together. So yes, this is definitely a relation. Now, is this relation a function? Some people would say, well, they've all got the same y values, but they've got a different x value. Well, let's make a little function machine here for a second. Is there any function where a 2 goes in, but then a 0 comes out? Or where a 1 goes in, and a 0 comes out? Think for a second, hit the pause button if you kind of want to think about it for a moment. Is there a function where that would work for all of them? Well, of course there is. If the function is y equals x times 0, absolutely this function would work. Because that means no matter what the x value is, it would always come out to be a 0. So 2 times 0 is 0, 1 times 0 is 0. So, while the rule stands that if you have the same x values, they must be paired with the same y values, the rule does not work the same way. Just because you have the same y values does not mean that you have to have the same x values. And this particular function right here, y equals x times 0, shows that you don't necessarily have to have different or the same x values to go along with all these same y values. So before we do some practice problems, I've got a couple more vocab words to throw at you. And you know how we math people just sit around and try very, very hard to confuse you poor little kids while doing math. One of the ways we like to do that is by giving a lot of different names to the same stuff. Well, so far in this video, we've talked about how x values, when we're talking about functions, are also called input, and how y values are also called output. So I'm going to throw one more in there for you. There's another word that we call domain, and that also means all of your, and the domain is all your x values. And then there's, of course, if there's one for x, there's got to be one for y, and that's called the range, and that is all y values. The way that I used to keep these two vocabulary words straight when I was in middle school is that D for domain comes before R for range in the alphabet, the same way that I for input comes before O for output, in the same way that X comes before Y. So all of it kind of operates in, well, it doesn't kind of operate in alphabetical order, it does operate in alphabetical order. So the domain is all your X values, the range is all your Y values. Now, let's look at some practice problems where we're going to kind of put all of this stuff together. Ooh, let's get rid of the answer keys. Second here. Cover that up. Can't make it that easy on you. So, for number one, it says, state the domain and range for each is the relation a function. Now, I should also point out that all of the examples that we've been working so far where it's asking whether or not it's a function, the problem's been given to us in the form of a relation or set of ordered pairs, but sometimes they'll give you the exact same values in the form of a table and ask you to determine whether or not it's a function as well. As an example, the one we just did a second ago, they might ask you, is this one a function? Well, of course, they already told you in the question that it's a function. But you can also assume, yes, it's a function because all of your x values are different. If you have all different x values, then you can assume that it's a function. Now, what if I were to make a little presto changeo here, and I were to change that 2 in the table to a 5? Now, this would no longer be a function because I have 2 5s for x values, but I have a 5 for a y value and an 11 for a y value. However, let me change it back to its original format. Because all of my x values are different, I don't have to worry about looking to see if they're with the same y values. So I would say, yes, this is a function. Let's go back to that example page that I was just on. Okay, number one, it says, state the domain and range for each is the relation of functions. Let's do the domain first. Remember, the domain is all of the x values. Now, a lot of the time you'll see it kind of does like this little squiggly line right here, like a little symbol like this for the domain. And so let's take a look at what all of our x values are. So we've got a -1, and I kind of mark them out as I go, a -3, a -2, a +2, a -5, and a +1. So those are all of the x values. Actually, let me clear this off here to show you guys like one example. So see, that's the little squiggly line I was talking about. And notice here they put all the x values in order from smallest to biggest in the answer key, and that's okay. Oops, let me cover up these answers for a second here. And that's okay. You can do that. Actually, that's the way you'll see it a lot of the time. So they said, yes, this is a function. The reason you can tell it's a function is that all of your x values are different. So you don't even have to bother looking to see whether or not they have the same y values. You can just automatically assume that, yes, it is a function. And the domain is all of your x values. So -1, -2, -3, -5, +1, +2. Okay, those are all your x values. Your ranges are -6, -9, 4, and 8. Now, and this one does kind of a weird order where it's like it goes from smaller, or it goes from bigger to smaller, because it goes from -1 to -5. Then it goes 1 to 2. It doesn't